Absolutely, and again, one of the visions that we've got is a very clear path on sustainability. We're looking for partnering with Earth space domain awareness companies, so that when we create our constellation, we're in partnership with that sustainable effort, the orbital data, orbital debris, and the space economy as a whole. We've got to look after that economy and enable it to thrive and grow. And again, we're expandable because, if we can send a payload into low Earth orbit, we can send it to MEO, GEO, we could assist lunar, I'm talking future tense now, but, we've created a platform for communications.
Good morning and welcome back to another episode of Making It Happen by Sims. Today we're taking a deep dive into a truly exciting venture our guest is working on and developing, and that's based around space-based data centers and storage solutions. So we have founder and CEO of AS23.Space, Barry Leeson, joining us today, who's going to tell us all about it. So morning, Barry, how are you?
I'm very well, thank you, Drew. Good
to meet you. So I think, firstly, before we get into it, and something I like to do with all my guests is, before we get into AS23, I think it'd be good just to introduce yourself, a bit about your background and your journey leading up to the venture that you're on at the moment.
Yeah, thank you very much, Drew. I was in the military when I left school. I was in the Royal Navy. I had 10 very happy years there. And on my departure, I become back in the 2000, it was what you could be was an IT consultant back then. But nowadays, it's such a varied, wide industry that's no longer the case. But so from that point, I've always been either self-employed or a contractor. I had a business. And then I moved into project management and data centers and low latency streaming. So my background is data, transfer, communications, telecoms. And I'd done that very well, traveled the world quite happily working. So yeah, I've got a few years behind me when it comes to data.
Great. And in terms of data centers, what sort of data center were you working in? Was it co-location? Was it cloud services or network? How was that?
Very much co-location, telehouse and some of the big players, tier one data centers. So yeah, I've been fortunate enough to be in some high-class areas, some sensitive areas, dealing with much different various types of data.
Yeah, and I mean that will bring us on to what we're going to discuss very soon in terms of data centers and the consumption on Earth and how that looks, and that market is growing rapidly, especially with AI at the moment and the demand. So I think let's get into that. So let's get into AS23 from its inception to now, and I suppose we should probably start with the mission and the problem statements of what you're trying to achieve and address. And I think it goes back to the advent of AI and that colossal growth of data. It means that Earth is being asked a lot of itself to cater for this growth. And I imagine that's probably where the story starts, right, in addressing those challenges.
Absolutely. I exited a business back in 2019. And then I sat there, had plenty of time to reflect what I was going to do. And we was looking at the data market, and as it was sort of merging the AI platform there, and as you say, the exponential growth of data and processing power. Data centers are being built by substations right next to all the resources that they need, and it's an exponential growth with it's billions of pounds being spent. And then, I always had a fascination for space. As a kid growing up, we was blessed with having the rocket launches and the satellite and the shuttles being launched. So again, it was a fascination, and I've had some experience in space data. So again, there's two angles from AS23.Space. Is we've got a space element of data and an Earth. So we initially went down the road of looking at space data, but as you say, it's very evident that the terrestrial Earth-based data processing with AI sort of expansion, it is very much of the now and present. And for sustainability, we have now positioned ourselves in a very nice area that we are looking to take off grid the data processing and storage off planet. And that it won't resolve the entire problem of sustainability. It's a very big problem, but what it can do, it gives a customer the choice. It gives the customer the option of being sustainable. And we're quite confident in validating that with, yes, we do need to launch payloads to achieve this. And once we're in orbit, then we're neutral. We're getting our power from solar. We've got our storage. We've got our communication. So we'll be operating at a fraction of the resources. And it's down to us as a company to develop that hardware where we unfortunately will have power constraints. But that's where our innovative development comes in. That we will be developing new processes to put this data in sequence. So hopefully that gives you a flavor. We are looking at it from a 2-channel perspective, terrestrial and space. But ultimately, my job is trying to encompass it all into one, so that we are a data company. We're not just a space company. We are a data company.
Great. And talk to me about the makeup of what you're doing in terms of the satellites and how you're putting it up there. I imagine you must be collaborating and working with a lot of people. What does that look like?
This is a very, very ambitious, big project. It's huge. So we've broken it down into 3 simple sort of segments. The first segment is under the name PB1, which is a petabyte of storage. And we're developing a single form factor of a petabyte of storage in the size of, let's say, a small shoebox. So very dense data storage. That's phase 1. Phase 2, we've got a project name of Colossus, and that's us developing an onboard computer for a satellite. And that will be multi-processor, multi-client, multi-use device. Again, very powerful. We're aiming for the size. The dimensions, I'll make it easy. We're looking for half the size of a washing machine for that payload. So again, really condensed. And then that moves us on into the Nebula data project, and it is only the project name. And that's where we have a constellation of these payloads in orbit acting as a data center solution. And the way that we're doing that is by working along the same lines as an AWS or a Google Cloud facility in orbit for use. So, Earth-based customers can offload their processing, offload their storage, and in orbit research and Earth observation, likewise, will do exactly the same. We've got a really tight timeline for that, but we're very confident that we're able to achieve that.
And will that be a public resource where it's shared resources, or would that be private and almost like a private cloud up there?
So to start the whole mission off, as I say, very ambitious. The PB1 project and the Colossus project will be sellable units. So we've got interest with like Airbus. We've got various different companies that we're in conversation with telcos. So that they're sellable units. When we get to that Nebula data project, that's our crown jewel. We will have that data center solution as our project, and that will be open to the public.
Got you. Okay. And in terms of the AI revolution that we're in at the moment, obviously, let's talk about your inception to now. So obviously, how long has the project been sort of the thinking and sort of coming to the fruition? Because AI is probably, since the invention or progression of generative AI in the last 3-4 years has kind of accelerated. But prior to that, did you have sight of what was going to happen with AI and just the need for such processing capabilities and the growth of data? So take us back to when you started.
So yeah, back in 22, we could see that this was emerging. Well, I mean, it's been around a bit longer, So you could see a sort of trajectory of where it could go. But as we've developed from 22 to 23, especially the growth, it has surprised us, and it has driven us to look at ways of AI learning and manipulation. And I'm very pleased to say that as officially we're still a startup, but as a startup in the development and research, we have the ability to shift tack ever so slightly, as long as we keep our end mission and how we achieve that. So, yeah, absolutely. The development side, we've not completely signed where we're going to be with the Colossus payload. We've got an MVP that we're working towards. But as an example, we are researching neuromorphic processing for AI capabilities.
Right.
And that's really something that could really transform the way that we use processors for AI.
Great. Okay, great. That's really interesting. And in terms of a timeline, when are you sort of hoping? What does the project look like as a whole from where it's at now until you guys are pretty much at that phase 3?
Well, we're very fortunate there. As I say, we've been working since 22, and we've had various journeys with UK Space Agency accelerator programs, some interjection from the European Space Agency, and we've got an agreement with Airbus Defence for a payload allocation onto the International Space Station for 2027. Right. That will give us a 12-month payload offering in orbit. So that's our very first sort of phase 1 in timeline. So 2027, we've got a lot to achieve in that time. So that would be the PB1 and the MVP, the minimum viable product for the Colossus payload. And we envisage from that, we will go from a TRL, probably from the end of that, a TRL, we aim to be at a 7. And then for 29, 30, we'll be at TRL 9, and then that would be us commercially able to start the development or creation of the Nebula data project.
Great, amazing. That sounds awesome. So in terms of a hardware perspective, let's talk about it, because obviously we're involved with you from the memory and storage side of things. Obviously, and I know you're working with some of our vendors there. What does the makeup of these look like, these systems completely? Because obviously for all of us here on Earth, and you particularly with your experience and what we know about it, we're used to data centers full of racks and cabinets, full of servers with aisles, hot and cold. How would this look up in the space? Because obviously you're talking to me in form factors, it's very small, from half of a washing machine size. How does a data center look in the sky?
So the way that would work is we're developing our hardware. So again, as a startup, we're fortunate to be able to develop a very low level. So we're using the terminology of software-defined hardware. So we are manipulating the hardware channeling through the software. A lot of it will be virtualized within almost a virtualized firmware. And then from that, as I say, the Colossus payload will be multi-processor, multi-client, multi-use solution. And to put that into a perspective of a data center, the way that we see that is that all these petabytes, and they're modular, so we could stack them to create more, power being an issue there. But the intention is that all these payloads will be interconnected with each other.
Right.
So once we've created, we've got a golden number. Once we've created this constellation in orbit of all of these satellites, which we're not going to make, by the way, we're going to partner, as you said earlier.
Yeah.
We will have the sweet spot where we will share resources across the entire constellation. And that would create that multiple racks that you're used to seeing in a data center. So from our constellation, we're envisaging probably about, I think it's in the region of about 100 racks from our constellation.
Wow.
And as you know, if you look at an AWS or you look at a Google Cloud, they span so many different servers, so many different different types of servers. So that's where our innovative sort of development needs to take its take its step. So, and again, I'm pleased to say that we've got very much good interest, and we're collaborating with AWS and Google. We've been in conversations with Microsoft this morning, finalising agreements. So the big players are really seeing this, and really, I do see that they're taking it on board.
Yeah, great. And I suppose that comes back to some AI capabilities. And in terms of your AI capabilities up there, would that be proprietary, or would that be built on top of sort of open models? Will you be integrating with the Azures? I suppose that's all up for discussion, right?
It is, and at this stage, again, we're at quite a low TRL, so we're in them discussions now. And I think if we look at the development of AI, I think we need to be sort of future thinking of that. We will be placing, hopefully, we need to be in a position where we're putting agents for clients in orbit, and let them control their own agent, and that could be. For space technology, that's at the edge, and for Earth terrestrial users, that's offloading. So we've got multiple avenues to investigate, and we're building a very strong team to achieve this. It's not me. I can assure you, this is a far bigger project than one person.
Yeah. So talk to me about that team. So I imagine you have people from product to CTOs, all these kind of people involved. What does the team look like at the moment? And obviously advisors, I imagine, involved.
I'm pleased to say I've got a team of 5 technical people working with me. And equally, I think the board of advisors now is bigger than that, with some real good players in there. And it's been a joy to achieve that over the 2 years that we've been formed as a company. I've spoke many a times about the vision of where we want to be, and it's started to take a lot of momentum, and that's not just my effort. That's the effort of society. There's a lot of talk at the moment about data centers. There's a lot of talk about space data. We're not the only ones talking about in-orbit data centers. We have our unique vision of how ours is different, and that's through that constellation instead of a big mass. It comes with challenges, and the team that we're building is looking to be a real good front runner for us.
Great, and that's really awesome. And just talk to me a bit about that competition, and don't have to go into specific names, but just obviously you mentioned the constellation element of it. But is there any other way that you guys differ?
Yes, I think we're not about putting great big chunks of hardware and large solar panels in orbit, and that's one, and that's totally viable. But one of the things that we're not reliant on with our vision is that we're not reliant on large quantities of payloads going into orbit. We're keeping ours quite a standardized form factor to collaborate with satellite manufacturers, to collaborate with scientists, researchers, and hopefully data center operators here on Earth. And that's alike, because we want to be that data center solution. You can't turn up and start plugging in your own equipment, I'm afraid. So, we have to, well, not at the moment anyway.
Who knows?
we have to be a solution instead of, a service. So if that makes sense at the moment, unfortunately, no one's going to go be doing some plugging in upgrades.
No, got you. And I think you hit a pretty important message there. Actually, it's very interesting that we're very focused at the moment on sustainability on Earth, but you're also taking a view of payload and what that looks like outside of Earth and in the orbit and what we're putting up there. There's definitely a mindfulness there from you guys, right?
Absolutely. And again, one of the visions that we've got is a very clear path on sustainability. We're looking for partnering with Earth observation, space domain awareness companies, so that when we create our constellation, we're in partnership with that sustainable effort of the orbital data, orbital debris, and the space economy as a whole. We've got to look after that economy and enable it to thrive and grow. And again, we're expandable, because if we can send a payload into low Earth orbit, We can send it to MEO, GEO. We could assist Lunar. I'm talking future tense now, but we've created a platform for communications.
Yeah, great. No, great. That's awesome. Very much aiming for the stars. So I just wanted to just touch back on the customer perspective and who this will be right for right now and in the future. And I suppose it probably comes back to, and just from my understanding, in terms of workloads and what you can do with your solution. So what does that look like in terms of workload perspective? Because we've mentioned AI and ML and all these things, but obviously other workloads that customers can expect from you guys. What can they do up there and how can it work? And just a bit more in that target audience for you guys.
So I'm pleased to say that we've got letters of intent. We're at a very early stage, and that's me going out being bolshy, selling what I haven't got, but I'm selling the vision. So we've got American telco companies, satellite telco companies that are more than happy to pre-order with us, especially for petabyte of storage in orbit. Again, that will be available terrestrially as we develop. If there is a market for that. We've got interest with blockchain financial organizations for data operations in orbit, insurance, and health tech. That's another area that we've got interest from regarding wearable technology, close to source, developments in that. And again, defense. We've got Airbus. We're in conversations with DASA, the NATO Diana Fund. So that there is an element there of defense dual use capabilities. I'm actively trying to seek them opportunities to say, look, come on board, have this sustainable effort from an Earth perspective, and equally in orbit. We're trying to make the research, development, and communications a lot more cost effective for people. It's very expensive to send data to and from space, so you want to be sending the right data and not the wrong data.
Yeah, definitely. And just thinking back to some of those areas, especially health tech and blockchain and transactional stuff, and latency is going to be a big point out. We're not really touched on that, and I just want to do that before we sort of finish up, because we spoke a lot about sustainability and power, but in terms of latency, in terms of the speed of data transfer from space to Earth, what does that look like?
So we're working on as low latency as we can. That's one of the areas that I've worked in for previous businesses before. And the low latency aspect, we are talking less than like 700 milliseconds for a complete touchdown. We will aim to get that better. Not forgetting the photonics, the laser communications that we're dealing with. We are looking to partner. We've got a few players that we're talking with, and that would dramatically reduce that and include the bandwidth size that we can operate with. So again, because our ultimate end is a constellation, they will be interlinked by photonics. And again, that latency will be vastly reduced. So latency is going to be there. I don't see it being an issue in our client base, as in having the ability to process that data means that especially in a space domain arena, you're literally sending much smaller amounts of data to Earth than what you would be originally.
Right.
A loose example, a typical data set nowadays with the advance of sensors and data capturing, you could be talking 600 terabytes. 80% of that information will be redundant. It's not needed. It's not used. It's not usable.
Yeah.
So if we can process that in orbit and reduce the size to less than 100 terabytes, you'll get that extremely quickly, and you're making life-changing decisions.
Fantastic. Great. Okay, brilliant. And I just want to sort of finish up now, and that's been a fantastic insight into the business and the vision. So I think what I would like to know is, and our audience, is just what have the achievements been so far for you guys? Where are you at in terms of partnership, funding, contracts? Where are you at, and what does the near future look like for you guys?
Yeah, I'm pleased to say we've had a lot of interest and a lot of support. The UK Space Agency has been very instrumental. We've won awards already, which was fantastic. We're in conversation and talking to the European Space Agency. Um, the the agencies have been fantastic with the support, so that's a good start. And then we've got that agreement with Airbus, the defence side of things, giving us access to the International Space Station. So again, having our payload in orbit on the International Space Station for us to demo, have access to that would be tremendous. And again, to all the partners, we are talking about creating a payload, and for us to get to that Nebula data, satellite manufacturing, photonics partners, software-defined radios. There's an entire ecosystem of additional companies that we will work with, and I'm pleased to say that them conversations are happening now. We've got a clear vision regarding the funding side of things. I'm on a funding frenzy at the moment, so if anyone's interested, I will gladly have a conversation. And it's a journey. I mean, the ticket size of the funding is reasonably large. It does put people off, but it's a case of, you know, we're a very ambitious team here, and to achieve what we're setting out to achieve, it is truly huge.
Yeah, it absolutely is. No, but it's there's so much to love about what you guys are doing and the ambition here, and what it means for us here on Earth, and the future of data, essentially. So look, Barry, it's been an absolute pleasure to hear from you today and to get some more insight into what you guys are doing. We will be following the journey all the way and bringing it to everyone in the future. And maybe we can catch up again in a year's time and see where things are at. But I really, really appreciate you coming on and being so open with us and explaining everything. So yeah, brilliant. Thank you, Barry.
Thank you very much, Drew. Really appreciate it.
Bye-bye.
Bye-bye.